Hi there, I'm Derivative.
I'm Annika girl.
And we're here today because we've been having some issues lately.
Just a couple.
I'm trying to find myself. I've hit a plateau in my life and I need to find who I am. And she won't accept me for who I am.
I can't deal with all of the change that's going on. I need continuity in my life.
I need to find some more. I need some more in life, and I need to be accepted and supported for what more I want to find. So I've been trying to find myself lately, and I've been figuring out all these different things. I can become a second derivative, even a third. I can also anti-derive. It's so exciting, and I love it so much. It's so fun to do all these changes, and I'm trying to have so much fun, and Inner Rule is not liking it. She's not being supportive. She's not understanding. Like I don't know how to, go through all these changes with her not helping or supporting me, and it makes me so sad that I can't enjoy these moments with the person I love.
I can't deal with all of the change that Derivative is going through right now. Anti-derivatives, first derivatives, second derivatives. I can't deal with this. All this change. All this change. I just need a steady, constant life.
Hello, I'm Tangent Line,
Hi, I'm Function.
and we're gonna try to solve their problems.
Yeah, I don't know how that's gonna go. It seems like they have a lot of issues that need to get aired out, but
Yeah, they're not that basic. So they got a lot of issues, huh?
yeah, hopefully the solution's not too complicated.
Hi there, welcome to the math pronunciation year. Today we'll start with derivative. A derivative measures how fast a function's output changes when its input changes.
Example, f of x equals x cubed plus 2x squared plus 5x plus 27. F prime of x, 3x squared plus 4x plus 5.
Ipopapola.
A symmetrical open curve with two distinct mirrored branches.
Example, they're both equidistant from the y-axis.
The abstract study of numbers, quantities, space, shapes, and patterns.
2 plus 2 equals 5. Geometry.
Branch of mathematics that studies the size, shape, and position of things as well as how objects relate to one another in space.
Equilateral. Isosceles. Parallelogram. Rectangle. Right angle. Acute angle. Obtuse angle.
I feel like she never thinks about what I went through to get to where I am today.
You feel reduced to your final value.
Exactly! People write me down, evaluate me, put limits on me, and move on.
Those limits sound restrictive.
They are. It's from 0 to 1. The next, it's a negative infinity to infinity. Nobody asks if I'm comfortable with that.
That sounds exhausting.
Don't get me started on improper relationships.
Improper relationships?
Infinite bounds, discontinuities, red flags everywhere.
Yet you keep trying to make those relationships converge.
I know, it's a problem.
Let's talk about your connection with derivative.
Okay.
Still complicated?
Everyone says we're just the perfect opposites. The fundamentals theorem says you're made for each other, but it's not that simple.
How so?
Derivative is always changing things, breaking everything down into tiny pieces. I'm the one who has to put it all back together.
You feel responsible for reconstruction.
Exactly! And somehow, derivative gets all the attention because how instantly everything happens.
Well, your work requires patience and accumulation of time.
Exactly! Every day I take on someone else's shape. Polynomial, exponential, trigonometric. I just keep adapting.
Perhaps adaptation is one of your strengths rather than a loss of identity.
You really think so?
I do. No matter the function, you create meaning from your change. You transform local behavior into a bigger picture.
I'm tearing up. What if I don't know the answer?
Not every integral has to be closed form solution.
That's comforting.
Some problems require approximation.
Numerical methods?
Numerical methods.
So it's okay to not have only a perfect answer?
Absolutely. Even mathematicians are willing to estimate when exact solutions aren't available.
I really needed to hear that.
Before you finish, I'd like you to try an affirmation.
Okay.
Repeat after me. I am more than my bounds.
I am more than my bounds.
My value is not determined by a single evaluation.
My value is not determined by a single evaluation.
I can handle change, even when it happens infinitesimally.
I can handle change even when it happens infinitesimally.
How does that feel?
Surprisingly continuous.
Good.
Thanks, Dr. Function.
You're welcome. Same time next interval?
Definite or indefinite?
Leave that open-ended.
Welcome, derivative. You mentioned some tension between you and integral. How are things going?
Not great. Integral says I only focus on small details and never look at the big picture.
And how does that make you feel?
Frustrated. My job is to focus on what's happening in the moment. I measure change, but integral acts like I'm tearing everything apart.
Have you talked to integral about that?
I tried. Integral says they're always cleaning up my messes and putting everything back together.
Do you think there's any truth in that?
Maybe a little. I do break things down into tiny pieces. Without me, integral wouldn't know what happened at each point.
So you both contribute to something important.
Yes, I help understand change, and integral helps understand the whole story.
Exactly. You're not opposites because you're fighting each other. You're opposites because you complete each other.
Like the fundamental theorem of calculus?
Precisely.
Maybe I was so focused on our differences that I forgot we're connected.
What would you say to integral if they were here?
I'd say, I'm sorry for not appreciating the bigger picture. Thank you for helping me make sense of all the changes I find.
That sounds like a great place to start.
Yeah, maybe our relationship isn't diverging after all.
It sounds like it's converting.
I'm gonna try something. I want you to solve for this equation for x to solve for the problem in your relationship.
Okay.
Now let's solve for x in this equation to solve for the problem in your relationship. 3x squared plus 12x minus 63 equals 0.
Okay, so you take the 3 out as the greatest common factor, and that's going to equal x squared plus 4x minus 21, all multiplied by 3, which equals 0. And then you factor the equation that's being multiplied by 3, and that's going to equal x plus 7 times x minus 3, all multiplied by 3. So x is equal to negative 7 and 3, which must be where I went wrong in the relationship.
Never give up meet up with function and integral.
This was great. Now let's go meet up with derivative and tangent line to end the day.
Yay.
Are you tired of spending hours trying to find derivatives? Do limits make you feel limited? There's gotta be an easier way. Introducing the derivative boost, the new and improved technological way for your calculus.
With DerivaBoost, you'll be able to find derivatives faster, understand limits with confidence, and conquer integrals like a pro. DerivaBoost, because success is not a limit, it's your destination.
So, derivative, you have to find the derivative of a position function to see where your relationship is going. Okay, so x of t equals 3x squared minus 2 in parentheses times 4x cubed plus 1.
Alright, so I'll start off with moving it. So v equals 4x cubed plus 1. U equals 3x squared minus 2. V prime must be 12x squared, and u prime must be 6x. Next, we'll set up as v of t equals 4x cubed plus 1 in parentheses times 6x. following, we will add 3x squared minus 2 in parentheses multiplied by 12x squared. After multiplying, we will get 24x to the fourth plus 6x plus 36x to the fourth minus 24x squared. Let's combine and we'll end up with 60x to the fourth minus 24x squared plus 6x. Oh my goodness, that's where I'm supposed to be!
Now we're also going to be taking the derivative of a position function to see where your relationship is going. X of t equals 12x to the fifth minus 8x to the third plus 3x squared plus 7.
V of t is going to be equal to 5 times 12 is equal to 60, so that is going to be 60x to the fourth, and then we're going to subtract 3 times 8, which is equal to 24, and x squared, and then add 6x to that, and then 7 equals 0. Our velocity functions are going in the same direction.
It must be meant to be.
Now we have to solve a geometric proof to prove our love. Our first statement is that VE equals OL.
Our first reason is that opposite sides of a parallelogram are congruent.
Our next statement is that line VE equals line ED plus line DV, and that is equal to line OI plus IL.
Our second reason is the addition property.
Our next statement is that ED plus DU equals OI plus IL.
Our third reason is the transitive property.
Our next statement is that line ED plus DV equals ED plus IL.
Our fourth reason is arithmetic.
Our fifth statement is that DV is equal and congruent to IL.
Our fifth reason is subtraction / the congruence property.
Our sixth statement is that the angle L is equal and congruent to the angle I.
Our sixth reason is that their corresponding angles
Our next statement is that angle I heart L is equal and congruent to angle V heart D.
Our seventh reason is vertical angles.
Our eighth statement is that triangle I heart L is equal and congruent to triangle V heart D.
And our eighth reason is ASA.
God, you idiots! Just write it correctly!
I'm sorry.
God, it's
was an
not that
accident.
hard!
It was an accident. I'm sorry.
You're just trying to sabotage our
No,
relationship.
no, I wouldn't do that. We just fixed it.
Try again. Our final statement is that I heart is equal and congruent to D heart.
9. Our conclusion.
One, 4, 1, 5, 9. This is pi followed by 2, 6, 5, 3, 5, 8, 9. Circumference over diameter 7, 9, then 3, 2, 3. OMG, can't you see? 8, 4, 6, 2, 6, 4, 3. And now we're on a spree. 38 and 32. And now we're.
That's probably good.
We don't know how that's gonna go.
Hi, Moxley.
Hi, plus C.
Why the heck is my apple ball open?
Something that is based on.
Oh, so Annika.
Oh, look, you should know.
There's an easier way. Introducing the derivatives, the revolutionary product designed for calculus.
From x squared plus 5.
Find the derivative.
Hi, puppy.
Derivative.
Hi!
Her whole half twitches when you do that.
Cut.
Cute.
He was.
Really? Yo, me too. Your face is so cute.
Here, come on. We're gonna go over here.
Say though.
Hi, I'm fine.
You can come out whenever.
I forgot what else to say.